The project is about the digit classification, and in this project this is about the basic neural network from scratch. In this project we have not used the PyTorch or any machine learning library. We have just used the scikit-learn library for importing of the dataset. So this is my internship project, and the topic is handwritten digit classification. I have used Python and NumPy. So this is my learning for a neural network from scratch. In the output we can see the model, the matrix and the visualizations. So the problem of this is that we have a data sets of the digits of the sklearn. We have imported the data set. There are 1797 samples. These are the 8x8 images. So that will become the 64 pixel dataset. Using the NumPy, we have flattened the 64 features into 1D array, and then we split up the data into the train and test using the NumPy itself, 0.2 ratio. The project structure is mainly considered in three parts: the main.py, model.py and the utilities.py. The main.py is the main controller or say main execution of the project. Model.py have the logic of the neural network and the model structure there. Utilities.py is the helper functions and the data set load feature there. In the plots we have saved the graphs of the accuracy and the loss, and the predictions of images is shown there. There is requirement of txt file, that is the dependency file will be shown in the VS Code. Basically this is the model architecture. Neural network is the network of the neurons in which there are hidden layer, input layer and output layer. Between them there are many of the hidden layer. In this our project we have used a single hidden layer. So as we have already known, there is the 64 input feature data input, 64 flattened 1D array of the input. Then the hidden layer has 32 neurons, and output is of the 10 neurons because we have like 0 to 9, 10 digits. So in forward propagation we have initialized the weights and bias for each neuron, and for each value in the x1. Then after transforming the value, the pre-activation value becomes, and then we applied it to the ReLU or the sigmoid activation function. So when the ReLU function is applied, there will be value becomes positive, and non-linearity becomes in the input. So it can learn the many feature. After the output layer there will be a prediction, and this predicted value and the labeled value we calculate the cross entropy, that is the loss, and using the loss we give it to backward propagation using optimized function gradient descent. In this process of the optimization we then use the chain rule and find out which weight has contributed for the error. Then we can update the weights, and this iteration repeats. We have used 200 epochs here. There will be the learning rate initialized 0.1. We have splitted the data set into train, that is the 1438, and the test data is 359. There is the accuracy about 93.04%, and the loss is about 0.41%. This is the accuracy, and it is increasing by the epoch number of increase.